Okay, so today's video lesson, we're going to go over what I call a cut list. So we've mentioned before that we are going to take this 1x6 pine board. And we are going to cut that so that we can have all of the pieces and use it to make this wood tote. So we will be cross-cutting these to length and then assembling that here in the next week or two, so as we make this particular project. So it's important to develop what is called a cut list or a diagram list that kind of takes your board and breaks it down so that you can have an idea of how you're going to process that board into the parts that you need to assemble and make the project you're working on. So we're going to do a little bit more sketching. We're going to use some more extension lines and dimension lines to draw this out and make this cut list. So let's go ahead and begin. So again, the first thing that we do when we want to represent that board is we're going to draw a two-dimensional object. In this case, if we think about our board, so the board's going to be like this. So we're going to be representing the width of the board and the length of the board in this particular drawing so that we have an idea of how to cut this up into its component parts. Now, it is important anytime that we are sketching or drawing, we always want to maintain some scale and proportion. So I'm going to talk about this, but I'm going to leave these up there just so you can see it and keep that in your mind. Scale and proportion. Right there. And this is going to be what we call our cut list. So we're going to draw that rectangle. Now, I know most of you, your first tendency is going to say, all right, Mr. C wants me to draw a rectangle, so there's my rectangle. Can you guys see that? So it's really tiny and small. So I've actually even had students that kind of do something like that. That's even smaller. Now, I noticed this about 5 years ago. Students started to really draw things a lot smaller on paper that have this big sheet of paper that then turn in and have a real tiny drawing on it. Don't do that. You've got paper, use that paper space. I kind of think it's because we're all kind of used to looking at our cell phones, and the small screens aren't our cell phones anymore, that we're drawing that way on paper too. But use that paper space. It's important. We're conveying information here. We want everybody to be able to see it clearly. So it's important to sketch that. Don't be afraid to use that paper space. So I'm actually going to draw this pretty big, to be honest with you. So we're going to come right over here. I'm going to draw this out. Notice how I draw that now. Now, with that being said, I'm going to kind of indicate. First off, let's just see how good my drawing looks like. There's my board. There's my drawing. Hey, not too bad. Pretty much looks like a long rectangle. Not that hard to sketch and draw, guys. You all can do it. So, and gals, kind of take some practice to put your mind and pen or pencil and get that fluid motion. But you guys can do it. You'll develop that skill, practice it. Picture is really important in industrial technology because it conveys information quickly. So there are my two extension lines. Now on the parts of the board, we mentioned that this was a W, and I put the W there for the width. Now we already know the width of that. We know that the width of a nominal 1x6 board actually measures 5.5 inches. And we talked about the difference between nominal size and actual size. So there I'm going to put my 5.5 inch dimensions there. And I will put these dimension lines. There you go. Those are the dimension lines. So, and now I'm ready to kind of start saying, okay, well, now I need to kind of get an idea of how I'm going to cut up this board so that I can make this. So, first thing I'm going to do is I'm going to start with the back of this. We're going to come in with our tape measure here. I'll take a measurement. So that measures at 16.5 inches. So bearing in mind and keeping the idea here of proportion. So in scale, I kind of, well, what proportion is 16.5 to 5.5? Well, if you think about it, it's roughly about 3 times. So when I draw my line here, I want to basically be about 3 times whatever this length is. Now, so you can kind of eyeball that and say, all right, well, I think right there is about 3 times the length of 5.5. Now, maybe it is, maybe it isn't. So the idea is that we're kind of given that representation. If you really want to be accurate, I could go 3 times. So I can kind of put my fingers here like this, and then I can just transfer 1, 2, 3. I was a little bit off, so that's not too much, but that's okay. It won't matter too much. But if you want to be even more accurate, you can do that. So let me darken back what those is. Now I'm going to do my extension lines here, and we will go ahead and put this dimension, 16.5 inches. There's my dimension lines. There. All right. Now let's take a look at the next part that we're going to take out of this. So I'm going to flip this over onto the bottom. You can kind of see. So we do have the back here. There's the front. We got 2 sides. Notice the bottom is kind of in between there. We're going to start out by making butt jokes here. This is a butt joint. It's the butt of all woodworker joints. So basically you butt 2 pieces up together against each other, and then we will either use glue or nails or screws usually for your butt joints to make them stronger. So it's called a butt joint. Let me measure this piece. Now this piece measures 15 inches. So that is the next piece here. 15 is smaller than 16.5, so we want to kind of maintain that proportion-wise. So we'll go just a little bit smaller there with that. And again, I will put that 15 inches. Now, if you think about it, 15 inches makes sense. So if our overall length is 16.5 and the thickness of the board that we're using is 3/4 of an inch, it makes sense that the piece that's sandwiched between 2 ends would be 15 inches because you got 3/4 of an inch, 3/4 of an inch on both sides. So 16.5 minus 3/4 is 15 3/4, and 15 3/4 minus 3/4 is 15. So that way it works out where everything will be nice and flush, providing you cut those exactly at those sizes and dimensions. So 15 inches. One thing I forgot, let's go ahead and label these parts. So this is the back. This is the bottom. So, all right. Now let's go to the next part that I need. So we're going to need 2 side pieces for that. So I will real quick, we'll measure these 2 side pieces. Both of those measure 9 inches. So let's go ahead. We will measure out, put 2 of these in at 9 inches. So now this is going to be a little smaller here, but they are both the same. So we want to kind of keep that scale. So, and I'll put 2 extension lines. Here's my 9-inch dimension. There's my 9-inch dimension. Another dimension line, dimension line, dimension line, and dimension line. All right. So and we want to label it. So side and side. If you want to do side 1 and side 2, that's okay. If you want to do side A, side B, that's okay. So whatever helps you keep these in perspective and helps you to understand what you're doing. Now, you didn't see this initially, but we do also have these 2 internal steps right there. Those are going to be put in there because they will hold the metal tray that we're going to be fabricating to go on there as well. So I'm going to real quick measure those. And those are 2 inches long. So they're going to go right there. So we also want to do this. Now, I did have to get this one right. Doesn't always work out, but I'll just split that in half and kind of come down there with my extension lines and mark 2 inches and 2 inches. And there we have it. That's our cut list. Now, here's my question for you off of this cut list. So now that we know all of those parts, we're forgetting one. I will mention this. We're forgetting the front. And that's okay. We're not really forgetting it. We're not going to cut the front out of a 1x6. We were using a 1x6. Notice this isn't as wide, so we would have to rip cut that down and make it shorter. So we actually are going to use a 1x4. we want to make this a little easier where we're just kind of cutting the length and not cross-cutting. We're not going to get into any rip cutting just yet. So we're just going to use a 1x4 for the front. So it's not going to be a part of this board. But I need to know the total length of this board so I know how much wood to have, or if I'm going to make this project and I want to go to the store and buy a lumber for it, I want to know what the length of the board is. So I want you right now to take your time. I'm going to stop the video for just a second and add up all of those dimensions. This is where your real world math comes in place here. So addition and subtraction of fractions is very common in woodworking, so we need to kind of know about that. So just take a minute here, pause the video, add up those dimensions, write it on your sheet of paper, and let's see whether you get it right. Okay, so hopefully now you've got something written down. So we're going to real quick add these up. So I'm going to kind of think in my head doing this. I don't need a calculator or anything with this. So if I go 9 plus 9 is 18 and 2, that's 20. So I know that I got 20 inches here. Now I can also take these two numbers, 16 and a half and 15, and I can real quickly add those in my head. So that's 31 and a half inches. So I got 31 and a half inches plus 20 inches, which is 51 and a half. And then I still have this 2 inches over there. So that means 53 and a half inches. Total length equals 53 and a half inches. So how many of you got that answer? So just out of curiosity, did you get that answer? Kind of set you up here, because if you got that answer, you're wrong. You did the math right, but we forgot something, and I was purposely kind of not saying this yet because I wanted to make a point. I want you to always be thinking about things. We have 1, 2, 3, 4, 5 saw cuts that we're going to be making out of this board. We have to, when we make those cuts, we're actually removing material from this board. Now, depending on the thickness of the blade that you're using, a saw blade, that is going to change. So on some hand saws, it might be a 32nd, might be up to 1/8 of an inch, depending on the size of the blade. So in the case of this, I'm going to say our thickness of the material that we're removing with each saw cut is 1/16 of an inch. So what that means is you're really going to have a space in between each of these. You've got to allow for that. When you make this cut, when you're figuring out your total line and your cut list, you got to allow for that space. Otherwise, you're going to end up too short when you cut. So this is 1/16 of an inch. We have a special name for that. That's called the kerf. So we got a 1/16 kerf. Now, that is the spacing that is the material removal on a board. So we got 1/16 there, 1/16 there, 1/16 there. Each time we cut, we are removing 1/16 of an inch of material. So 1/16, 2/16, 3/16, 4/16, 5/16. We have to come back down here and add 5/16 to 53 and a half inches. So how do we do that? Well, we got to convert one of these numbers, because if you recall, when we are adding fractions, we have to have the same denominator on it. So I'm going to come back in here, 53. We'll keep the whole number like itself, but I got to think about how can I get 1/2 in some type of an expression that gives me 16 in the denominator. Well, if you realize this, 2 goes into 16 8 times. So that means 8/16 is the equivalent of 1/2. So I can just take and convert 1/2 to 8/16 and add 5/16 to it. Now I can actually add these together. Now, if you don't recall or not sure how I got to there, just talk to me about it. So we will get you on board so that you can make these simple calculations in your head pretty quickly as well. So, and I'll be glad to help go back over that and review that with you so you can know with 100% confidence that you're going to be able to do this. So, all right, so 53 and 8/16 plus 5/16. Well, all I got to do here, I'm still at 53. 8 plus 5 is 13. So 53 and 13/16 is the total length of the board that I need. So now, I mentioned before that you were basically going to roughly get a 5-foot long board. So the size of nominal size is a 1x6 by 5 foot. So first two, the thickness and width is in inches. The last is 5 feet. So just as another sense of review, if we say 5 feet, how many inches are in 5 feet? Well, there's 12 inches in a foot. So if I've got 5 feet, 5 times 12 equals 60. So I have roughly 60 inches. So 60 inches definitely gives me plenty of material. It actually gives me a little bit extra material in case I mess up there for this particular project. So I'll have a little bit of leftover. So, all right. I also want to point out when we're talking about the symbols here. The foot symbol is just 1 dash. It's up to the upper right of your numeral. The inch symbol is 2 dashes in the same place. Make sure that you're aware of that inches versus feet symbols that we're talking about here. If you prefer to kind of do the abbreviation, that's okay. You can also say 5 feet equals 60 inches. So that's the abbreviation there. That's all right as well. You'll see that pretty common in woodworking, building plans and so forth. But you just have to know and remember what you're looking at. So now, one other thing that I did in class earlier today is we also said, well, if I have 53 and 13/16 here, and this is in inches, how can I convert that to feet and inch? So I want to know what that would be, and I want to express that as feet and inches, not just inches. So here's a quick reminder. So I use my fingers on this one. So if I know that 12 inches are in a foot, so I can just go 12, 24, 36, 48, 60 gets me too much, so I go back to 48. So now I got 53 minus 48, so I got 4 feet. So 4 feet. 53 minus 48, count 3, 2, so it's 5. So 5 and 13/16 inches. So this would be 4 feet, 5 and 13/16 inches would be the way that I would express that in both feet and inches. And again, it becomes fluid after you do this a while. You have to kind of be familiar, kind of expressing these numbers in lots of different ways in the construction or carpentry trade, whether it's feet, whether it's completely inches, whether it's foot and inches. Now, as you're beginning to learn, if you're getting confused, I recommend just stay in inches. So do everything in inches. But see me, we'll work on making sure that you can go back and forth between feet and inches pretty easily as we go. So that's today's lesson here on the cut list and how we will process that particular board and get it into ways. Once we do that, we can begin to measure, mark, and lay out these onto our actual board, and we'll start doing the saw cuts next time in class. So thanks for watching. Hope you have a good day.